Now, if you're taking the approach of simply importing data into a data worksheet to obtain your data, then you can go right ahead once you have that worksheet in place. You can go ahead and create any reports or dashboards that you need to make based on that data worksheet. But if you are taking the approach of setting up a formal data source like we did initially, where we set up a connection to our sample database, then what you next need to do is to either create a query or create a data model or create a data worksheet. In other words, you need some mechanism to draw the data from that data source so that you can build reports and dashboards on that data. In this example, what we'll do is we'll show how you can create a data worksheet to effectively construct a query to retrieve the data that you want. Note that what we'll do is different than the data worksheet that we made before. The data worksheet that we made before, we simply created an embedded table and imported data directly into that table. Now what we're going to do is we're going to create a data worksheet, and this data worksheet will draw data from the formal data source that we set up. And that means that the data worksheet that we're about to create will always be populated by the data that's currently in the database. So because we have a live connection to our data source, the data worksheet that we're about to create will always be retrieving live data. Okay, so let's begin. To create a new data worksheet, press the New button in Style Studio. And then, as we did before, click the Worksheet option in the left panel. There's nothing to select in the right panel, so press OK. And that again gives us a brand new worksheet. Now, what we're going to do is expand the data source node on the left and then find the sample data source that we created. Remember from a few moments ago, we created a connection to our sample relational database, and we called that data source, that connection, sample orders. So here it is in the list. Expand that. And then in there, expand the table folder, and that will display a list of the tables in this relational database. So again, remember that the sample orders data source that we created is just the connection to an actual database, which in our case is a sample Derby relational database. So we set up this connection, and that allows us to see the tables that are contained in that relational database schema. So what we're going to do now is select some of these tables so that we can build a result set that we want to use in a report or in a dashboard. So what we'll do is we'll select the customers table. So I can just click and drag on the table and drag it into the data worksheet, and that appears as a table. As I mentioned before, sometimes we'll refer to these also as data blocks, and I'll say in a moment explain why we use that terminology, data block and table. So there's a customers table. You can see that it contains a set of fields that relate to the customers. Customers in this case are companies. So you'll notice that one of the fields is a company name. That's because the customers here, in our sales example, customers are actually companies. So there's a customers table. Now we're going to drag the products table. So click and drag on the products table to add that table. And then we'll also grab the orders table. And then finally the order details table. So we've got a set of tables now that we've drawn from the relational database schema, and you'll notice that each of these tables is displaying metadata by default. Right? This is not the actual data where you see XXX. That means that this field contains a string type data. Where you see 999, that means that the field contains integer type data, and so on. So these are just designations of the type of data that's contained by these fields. We'll see shortly how you can actually populate these tables with actual data drawn from the database. Now, the reason that we refer to these tables also as data blocks is because when you're building a data worksheet, you can draw fields, or rather draw data, not only from a single data source as we're doing here, but from any of the data sources that are defined in the data source listing. In the data source listing, you might have, for example, a relational database data source, as we have here. In fact, we have two of them, the orders data source and the sample orders data source that we created are both relational database data sources, and they're both based on a Derby database. You might also have in your list of data sources, say, an Oracle data source or a SQL Server data source, or even data sources which are not relational databases. You might have a text data source or XML data source, Java object data source, and regardless of what the particular type, what the particular structure of that data source is, you can drag elements, drag fields, drag tables into the data worksheet. And so the reason that we use that terminology data block is because it doesn't matter where these tables come from. Within a single data worksheet, you could have tables that are drawn from an Oracle database, a SQL Server database, a text file, an Excel file, a Java object data source, and they all play on an even field within the data worksheet. And that is where the terminology data block comes from, to highlight the fact that once you bring these assets within the data worksheet world, then they all behave simply as data blocks. It doesn't matter where the data came from originally. So we'll use the terminology table and we'll use the terminology data block interchangeably. Now, the next thing that we want to do is we want to take the fields from these four tables and bring them into a single table, into a single data block. And once we have a single table that has all of the fields from these four tables, then we can pick and choose which of those fields we want to retain in the final result set. Now, getting the fields from these tables into a single table is not simply a matter of just taking the records from one table and sticking them next to any old records from the other table. Rather, we have to specify how these fields relate, in these different tables, relate to one another. For example, in the products table, we have a list of information that describes different products. For example, the price of the product ID, the product name, the order level for the product, and so on. In the order details table at the bottom, we have some information about particular order, the order ID, then the products that are on that order. So for a given order, there might be more than one product and the quantities of those products. So if we want to bring the three fields from the order details table into the same table with the various fields from the products table, we need to make sure, for example, that the product ID from the products table matches up correctly with the product ID from the order details table. In other words, on a given row, if the product ID that we take from the order details table is, say, product 312, on that row, we should make sure that we have the information for product 312 listed, right? So when we go about putting all of this information into a single table, we have to make sure that we're going to match up corresponding columns so that on a given row in the result set, we have information corresponding to the same product, to the same order, and so on. Okay, so doing this is what is known as a join. So when you're combining together multiple tables into a single table, this is called a join. There are different types of joins. The one that we're going to do is the simplest kind, which is called an inner join, where the matching condition that synchronizes the values in these different tables is simply an equality match. For example, that the product ID value here should match the product ID value here on a given row. Okay, so let's see how we can do this type of join. There are actually two different ways to do joins. The quick way, which I'll just illustrate, you don't have to do it, but a quick and easy way to do a join is simply to drag one field on top of another field. So I'll just illustrate, and then I will undo the change, and then we'll do it a different way. But to illustrate how this is done, you can click on the product ID field in the products table and simply drag that on top of the product ID field in the other table, and that gives you a join symbol indicating that when I release the mouse, these fields will be joined together. And the result is that we now have a new table down below. This table has all of the fields from the two tables that I just joined, the order details table and the products table. And you'll notice that there's a link between the product ID field from the products table and the product ID field from the order details table. The two tables are shown side by side. And this link with an equal sign means that in every single row of this result, the product ID column here the value in that column is going to be exactly identical to the value in the product ID column here. Therefore, we've synchronized those two tables on, or joined those two tables on the product ID fields. So that's a quick and easy way to do an inner join simply by dragging one column header on top of another column header. Now I'm going to undo that change by pressing the undo button in the toolbar, and now we're back to where we were. And the reason why I'm going to take a different approach here is because I don't need to do just a single join between two tables. I actually need to join four tables together. And if you're doing a multi-table join like that, it's actually easier to do it using the join button in the toolbar. So let's try it this way. Select the four tables. I did that just by clicking and dragging across the four tables to select them. And then from the buttons at the top, we're going to look for the join button. It's the rightmost button on the toolbar. If you hover the mouse over it, it says inner join. Press that button. And that opens the inner join dialog box, and this allows us to, in a single action, set multiple joins between the selected tables. And so the advantage here is that I can do all of the three joins that I need to do. There's four tables, but I'm going to specify three joins between them. I can do that all in one operation. So that is a little bit simpler than clicking and dragging on the column headers in this case. So let's set the joins. The first join will be customers1.customer ID. So the customer ID field from the customers1 table should be equal to, and then from the right menu select orders customer ID. Okay, so in the finished result that we're building up, that will contain all of the fields from these tables, I want to make sure that the customer ID field from the customers table on a given row is identical to the customer ID field on the orders table. In other words, I want to synchronize these tables on the customer ID field. Next, we'll synchronize on the order ID field. So from the orders table, select the order ID. And in the right menu, for our second join, from the order details table, select the order ID. So we're synchronizing on the order ID, meaning that in a given row of the final result, we want to make sure that the order ID from the orders table, that the value in that field exactly matches the value of the order ID field from the order details table, so that we get for a given order on a given row where we're looking at the same data strictly for that order for that customer. And then finally, our third join from the order details table, we'll select product ID, and on the right side from the products table, select product ID. So again, what we're specifying here is a set of conditions that must be enforced on every row in the final result. And that basically specifies that in every row in the final result, we're looking at a particular data for a particular customer, a particular order, and a particular product in that order. Okay, now just another word. Some of you may be familiar with the concept of an outer join. What we've done here is an inner join or an equijoin. The concept of an outer join is where you desire to preserve all of the records from one or more of the tables. For example, in this case, we're only going to preserve records where there is a match between the customer ID field in the customers table and the customer ID field in the orders table. If it happens, for example, that there's a value for the customer ID in the orders table that does not exist in the customers table, then that value is going to be removed. In other words, it's not going to show up in the final result. In some cases, you might want to preserve that value, in which case you would enable the include all values option. And that is the concept of an outer join. So if you want to specify an outer join, you would either select the include all values option on the right for the corresponding table, or on the left. This gives you the concept of a left outer join versus a right outer join. If you select both, meaning you want to include absolutely all the values from both tables, even if they don't have a corresponding match in the other table, then you can also select both, which gives you the full outer join. But in this case, we simply want a basic inner join, so we're going to leave it just like this. Once you're done setting up the joins, press OK. And now down at the bottom, there's a new table. If you look in the title bar of the table, it shows you that this table is a join between the customers table, the orders table, the order details table, and the products table. And this result is shown also in metadata view. This particular view is actually called composition view because it shows us the composition of the table. In other words, it shows us that this final table down at the bottom is being composed from the customers table, from the orders table, from the order details table, and from the products table. So each of these tables is placed side by side, and it illustrates the conditions that are in effect in this result, the join conditions that we specified. For example, the product ID field from the products table in every row must exactly match the product ID value from the order details table, and so on. So we have the three joins that we specified, and they're all shown here. If you need to change one of those joins, what you can do is you can click on the join to select it, and then right-click and select Properties, and that will allow you to change that particular join. For example, if you got one of the joins wrong, if you made a mistaken selection, you can change it. If you need to change the join operator, which we don't need to do in this case, but in some other application you might want an inequality join, you can change that, and so on. Now, we don't need all of the columns that we have in this table. You can see it's quite a wide table. And we know, in fact, that some of these columns are redundant. Everywhere, for example, that we have a join, that means that there's a redundant column because the joined columns are identical by definition. That is the effect of the join operator, is to make sure that the values in those columns are the same in every row. So we certainly don't need duplicate columns like that. But in fact, we're going to actually hide many of the columns here, and we want to preserve only a few of these columns. So to do that, what we're going to do is, first of all, switch this table from the current composition view into the default view, which is a standard metadata view like we have for these other tables, and that will give us access to the hide operator. You'll notice that in these other tables, when you move the mouse over a column header, there's a little eyeball, and that allows you to hide or show a given column. And so currently we don't see that in the bottom table because it is in composition view, and we cannot hide columns in composition view. Simply move the mouse over the title bar of the table, and on the right side you'll see a set of buttons. If you don't see that set of buttons there on the right side, then perhaps try scrolling to the right and you may see them there. But they should be visible even if you're scrolled to the left. And the button that we're looking for here is the Change View button. In fact, I'm going to scroll this just so that the menu doesn't go off the screen. So what I want to do is click on the Change View button. Currently, it indicates via the tooltip that we're in composition view. But if I click on that, I can switch this into default view. So select the default option, and now this table is put into the default view, which, as I mentioned, is the view that these other tables are in. It's basically a metadata view. You see the metadata for each of these fields, but this gives us the opportunity to now hide the fields that we don't want to see in the final result. So I'm going to go from left to right, hiding the fields that I do not want in my final result set. So I'm going to hide address, hide city, company name we'll keep, customer ID, and all the other ID fields we're going to hide. So hide customer ID, hide region ID, hide reseller, hide keep state, hide zip. The customer ID field will hide. We can hide discount, employee ID we can hide, order date we'll keep, order ID we can hide, paid we can hide. Now here we have a duplicate column, order ID again. That's one of the join columns, so we can hide that. Product ID we can hide. Quantity we'll keep. Category ID we can hide. Description we can hide. Number in stock we can hide. Price we'll keep. Product ID we can hide. Product name we'll keep. Reorder level we can hide, and supplier ID we can hide. So we'll see in a moment if we missed any. So I've hidden a bunch of columns. Now, if I want to see what the final table will look like, obviously this view is still a little bit complex in that sense, because I'd have to look very closely to see what columns are going to be present in the final result. But what we can do is we can switch this table into yet another view, which is the live preview view. So if you click again on the rightmost button in the table and select live preview, okay, and now we'll have to scroll back, because now that the table is displaying the actual data, the actual data in the result set, these are the only columns that we're seeing, so we have a much smaller table now. If you want to move any of these tables around, you can just click on the title bar and drag them as you wish. So this is the result set that we created by hiding all of those columns. So what we can do now is we can change the names of some of these column headers. But before we do that, let's just expand the table slightly so that we can see the actual data. Currently, we're only seeing one row of data. That's the reason that the table is as short as it is. But if we simply click on the bottom border of the table and drag it down, then we'll be able to see that, in fact, this table does return more than one record. It has quite a few records. And in fact, if you look down in the status bar at the bottom with the table selected, it indicates to us that there are almost 4,000 records in this table. Now, as I mentioned earlier, when you're looking at a table in live preview mode like this, in some cases the number of records might be truncated. This is a setting that both you as the designer can put in place, and also an administrator might have a limit on the number of rows returned. So if you want to be sure that you're looking at all of the data, what you can do is right-click on the table and select Preview, and that will open up a separate tab, and this version of the table will contain, in general, all of the data. And so again, you can scroll through the data, and you can see that, in fact, there are almost 4,000 records. Okay, let's close the Preview tab, and I can make this table a bit smaller. Doesn't need to be that large. And let's go ahead and change the names of some of these column headers. We can do that either in this live preview mode, or we can do that if you want to conserve space. You can put the table back into default mode and change the column headers in this mode. But because of the width of the table in the default mode, it's probably easier to do this in live preview mode. So let's switch back to live preview, and let's change some of these column header names. Okay. Company name, you can change simply by double-clicking on the column header. We'll change that simply to say company. State, will just change the case so that it's uppercase. Order date, we can change to 2 words, order date. And quantity, simply like that. Price. And then product name will just change to product. Let's also change the name of the data block itself, the name of this table. Currently the name is query 1. We can change this and change the name by right-clicking on the table title bar, select properties, and let's change the name instead of query 1 to order data. And then press OK. Okay, so what we've done here is we've essentially brought into the data worksheet several of the tables from our data source that we created. These are the tables that we brought in here are actual tables from the database schema. And then we created a join between the 4 tables that we brought into the data worksheet. And that join gave us this result at the bottom, so that we now have a single data block that contains fields from the 4 base tables that we started with. So this result now has among the columns here are columns from those above 4 tables. And then we selectively chose which columns to show and which columns to hide by changing the visibility on the columns. And this gives us our final result set, which we're displaying here in live preview mode, and we changed some of the column headers. And this is the result that we're going to now use in the report and the dashboard that we're going to create as we go through the rest of this training. Now, before we save the data worksheet, let's just do 2 more things. First of all, I want to mark this data block as the primary data block. To do that, right-click on the data block, the bottom data block, Order Data, and simply select Set as Primary. And you'll note that now in the title bar, the name of this data block is in bold print, and it's designated as primary. This means 2 things. With regard to dashboards, when we build a dashboard based on this data worksheet, a dashboard is able to access any of the data blocks in the data worksheet. So when we build a dashboard, that dashboard can pull data from any of these tables in the data worksheet without any difficulty. However, the data block that's marked as the primary data block will always be listed above the other data blocks to indicate that this is the main result of the data worksheet. Now, when we design reports, it's a little bit of a greater importance that the primary data block has, because when you're using a report, when you're creating a report based on this data worksheet, that report only has access to the primary data block. So whereas a dashboard can access any of the data blocks, any of the tables in the data worksheet, a report can only access the primary data block in the data worksheet. So since we do plan to create a report based on this data worksheet, and in fact based on this bottom data block, it's important that we do designate this as the primary data block. The other thing that I'd like to do is I'd like to add 1 more column here. I'd like a total column, and that total column will give me the product of the price and the quantity. So I just want to take the price and multiply that by the quantity, and have that as another column here in the data block. To do that, we'll create an expression column. Create an expression column by pressing the FX button in the title bar of the data block. It's the expression button. So press the FX button, and that asks us to enter the name of the expression. This will be the name of the new column, so you can enter total as the name of the new column. Press OK. And that opens the expression editor. And this is an editor where we can write an expression either using SQL syntax, database syntax, or using JavaScript. That choice we can make up at the top. In general, writing an expression as SQL will be more efficient because the database can process that, and the syntax that you use should be the appropriate SQL syntax for whatever database this will be sent to, the database that has the data. In some instances, though, it's difficult to create the logic that you want using SQL, in which case you can also use JavaScript, which you would signify by selecting the script option. In this case, we can write this as a SQL because it will be very simple. It's just the quantity multiplied by the price. So you'll notice that there's a dummy expression already in place here. I will delete that. And then from the fields list on the left, let's find the price field. There's the price field. I just click on it to insert it into the expression. Then I type a multiplication symbol, the asterisk. And then I'm going to find the quantity, which is over here. Again, just click on it in the list to insert that field into the expression. And this is my expression. It's simply the price times the quantity. There's no need to assign this result to a variable, and there's no need for any return keyword. When you're writing an expression, you just write essentially the right-hand side of the expression, and that's it. It's understood that this is the result of this computation will be returned as the values in the column that we're creating. So once you've written the expression, press the Save and Close button. It's the leftmost button at the top of the editor. And that gives us our new total column, and because we have this in live preview mode, those numbers are displayed as are all of the other numbers in the data block. So now we have a column that gives us the totals. Now, The data block that we've created, as with these other data blocks all represent queries that are sent to the database. So each of these data blocks, even though it looks like a table, it's graphically designed to look like a table, behind the scenes, really what it is a query that gets sent to the database. And then the data comes back from the database and populates the table. So you can think of each of these data blocks simply as a query that gets sent to the database. If you want to see what that actual query looks like for any of these data blocks, you can right-click on the data block and select Show Plan. And the Show Plan displays the query plan down at the bottom, and it shows you exactly the query in SQL syntax that is going to be sent to the database in order to bring back this results that it gets displayed in the data block. And we can do this for the data block at the bottom as well, which will be a bit more complex. Right-click, select Show Plan, and you can see that this is a bit more of an involved query. It includes some joins, and the expression column is over here, price times quantity returned as column total. So at any time, if you want to investigate exactly what query is being executed to populate a given data block, you can use the Show Plan option. Okay, let's go ahead and save the work we've done. We have a worksheet now. This worksheet is finished, so press the Save button. We'll save this as Order Data Worksheet. Order Data Worksheet. Press OK. And now this worksheet has been saved. And as I mentioned before, when you save a worksheet, all worksheets are saved into a single file, again called asset.dat. And that file is located in the current working repository that Style Studio is using. And that was the current working repository we had set up earlier.